Okay,
Perfecto.
so we're supposed to be live right now, hopefully. Let's see. In the meantime, okay, yes, we are officially live right now. There's a bit of latency, so that's why you are not seeing the screen. Okay. So hello, everyone. Let's wait for a couple people to join. I
Hello.
know, yeah, okay. Um, Great. So already a few people are attending. That's great. Hi, everyone. It's very nice to see you again, or I mean, at least meet you again. Even though you can technically see us, we don't technically see you. But it is very nice to see that there are a couple of people joining. So please send us a message. Okay. Hello. Hi. So yes, please send us a message in the chat if you're here, if you're ready. We're gonna wait for a few more minutes and then we're going to start right away. So, well, first of all, I think, oh, hi from Paris. Wow. Okay, where are other people from? Wow, Paris. It's great. Um, so in the meantime, while other people are joining, as you probably already know, this is a chemistry focus event. Since the IMAT test, it's going to be on the 17th of September, so in not that long. We thought that it would be best. Wow, from so many countries. Turkey, Kazakhstan, Brazil, Cyprus. Wow. Oh, wow, so many countries. That's great. Romania. Okay. Yeah, you guys are basically from all over the world. That's super nice. We're so happy you're joining us today. And as we said before, we know that chemistry it's kind of a, harder subject and sort of how do we say it, like tricky subject. What would you say, Madeline? Um, yeah, so basically that's
Yes, tricky is the word.
yeah, I think that's the only word that we can, kind of uh say for it. So we thought that it would be best to have just a focus on chemistry and to look at the harder exercises that, are present in this huge topic and kind of like break them down a little bit together. So without further ado, let's start. If other people are going to be joining, well, there's just going to be an introductory part. So again, who are we? Oh, I guess there's a problem about the microphone. Oh, okay, wait. There's a problem on the microphone, so maybe if I do this, is it better? Maybe. Can you hear me better now, guys? Okay, thank you very much. Good. So, oh, good. I was scared. Uh, who are we? First of all, we are students for students. So we're me and Madeline, who is gonna introduce herself in a little bit before with this event. We're all medicine students. Actually, in Testbusters, we're just university students from different faculties, but both me and Madeline study medicine and English. And we are basically students that have passed the medicine test and especially the IMAT test, and they want to help you do the same. So we teach different subjects. So we see the logical reasoning is red, biology, which is a subject that I personally teach, is green. Madeline instead teaches chemistry, which is orange. And last but not least, maths and physics, which is blue. So these are a bunch of our teachers. We are basically actually all over the world. So we're mostly in Italy, but then some of us are in Oxford and Cambridge. So our team is getting bigger and bigger. And what do? We do free university orientation, like one of our previous events, the IMAT Orientation Day, advice on IMAT based on our experience, personal coaching for a specific study plan. We also have online and, in some cases, if you're in Italy, which is not the case for basically all of you, in presence courses, an exercise book, and also very recently an online ebook were for the theory. So a theory online ebook, which if you're interested, it's still available. Online simulations like this one and online support. And we recently just launched our first summer school. So basically a bunch of students from all over the world came here in Milan, where I'm actually at, and did a few in-presence courses for preparation of the IMAT, and they found out a bit more about Italy. We brought them around, we did different trips, so it was very fun. This is basically what we do. But what are we going to do today? We're going to do a chemistry simulation, just chemistry questions. So I think if you are struggling with chemistry, then this is your life. And a correction that Madeline is gonna very well explain the most important things and the most important topics for you. So, who are we? My name is Chiara, and I am, I mean, here it says fifth year, but I'm actually, since it's almost September, I'm about to start the sixth year. I'm old, I know. The International Medical School of the University of Milan. Yes, this live will be saved and will be recorded. Don't worry, you will find it on our profile, which is I'm at Medschool IT. So don't worry, you will find all of this live recorded. Okay? And now, Madeline, you can introduce yourself.
Well, hello everyone. I'm Madeleine and I'm from Turin. I'm a second year student, almost third year. And as Chiara said, I teach chemistry. So today we're going to do chemistry together. And yes.
Yeah, I used the English pronunciation. I'm sorry. Should have used Madeleine. I'm sorry.
You're okay. You're okay.
Okay, so without further ado, it's time to start the simulation right away. Yes, we are not going easy, we're going in strong. So please click on imatsimulator.testbusters.it. That's the where you will find our personal simulator. And we suggest to use the browser Chrome. You have to enter with the email with which you registered to this event, or you can create an account right now. But that's here basically it's where you have to put your email. And you have to check then your email because you will receive a code to access the simulator. Okay? So this is basically all you have to do. Please, guys, tell me when you're in so that we can move on to the next important thing, which is where you can find the simulation. I think people are still having some trouble with the registration and all. Okay, so once you've registered, please tell me if you guys are having any problems or if it worked out just fine. But once you registered, where will you find the simulation? You need to click on simulations right here. Okay, thank you, Sophia. Sophia's in. Simulations, click on free simulations right here. And yes, it is that one. Focus Chemistry Chimica Agosto 2024. This is in Italian. But yes, it's Focus Chemistry August 2024. So this is the simulation that you need to look at. Great, good job. It's okay, don't worry, take your time if you're not in yet. And once you're ready, you can officially start the simulation. You will have 1 hour of time, but this is how you find it. Exactly. You can click here. Okay, so a lot of people are in. That's good. I'm super happy. Now that you all found this simulation, if you haven't, please tell us in the chat. We will try our best to help. You have 1 hour to do the simulation, so we will be back with a correction once you're done. And so, by me and Madeline, Good luck. Timer starts now.
Good luck.
Okay, guys, I'm back. So sorry to bother you, but actually, there's been a slight mistake. The live is supposed the simulation is supposed to be done in half an hour. So you're not gonna have 1 hour, you're gonna have half an hour. So you're gonna meet back here when this timer runs out, okay? Thank you very much for your understanding, and I'll leave you back to your simulation. So time is up. It's time to start again. So I see that more people are joining in. That's great. So before we start with the correction, so Madeline takes the stage. This is really important to us. We have an evaluation questionnaire. And since this is one of the first times that we do an event like this, improving and having some feedback for you, it's extremely important. It's a very quick questionnaire. It only takes a couple of minutes, but please do fill it out because it really does help us improve. And also for the next events, tell us what you want, tell us what you like and what you didn't like. So please scan this QR code and fill it out. Okay, now how did the simulation go? Before we start again, please, if you're interested, we have a lot of tips and quizzes, and also the recent news from the for the IMAT 2024 that we will post firsthand on our Instagram. So scan the QR code or follow us on imat.medschool. It is if you want to stay updated. Or again, you can check out our blog. We have university guides, the online simulator that you just used. I'd like to remind you that until September the 4th, there is a free simulation that you guys can access and that you are going to be able to see the national ranking too. So you're going to be able to see how well you did compared to others, and our Instagram quizzes. So please do check it out. And if you like this event and you would like to know more of what we do and what we are, we have an IMAT Lab course that is starting really soon, because you're going to be able to do all of these exercises and more. So Madeline is going to give you a bit of an insight on how we teach and how we explain in our practice and revision courses that are going to be from September 5th to September 15th. And with our live course, you're gonna able to access also the theory lessons, a complete IMAT question bank with over 1,300 quizzes, and our brand new IMAT Essential Theory ebook. This is the first of the ebooks that I've seen that has been developed like this. So, and I think that people have really been enjoying it. So we're very glad. But please do check it out if you're interested, or if you like this event and feel like you'd like a little bit of a guidance from us. Okay? Without further ado, Madeline, please take the stage. It's time for the correction.
Thank you. So how did the simulation go? Did you find it hard, difficult, easy, medium? Let me know. So we're going to start from the first one. And sorry if I'm not looking at the monitor, but I'm looking at the simulation here. So the first question is telling us to choose which one of these statements is sorry, just it's not working, the slide here. Okay.
Yes, now it's working.
Okay, perfect. So it's asking us to identify the incorrect answer. So please always try to pay attention to what the exercise is asking you. In this case, the correct answer is the number C, because it says that the mass number indicates the number of protons in the nucleus of an atom. This is actually incorrect, and this is because the mass number not only indicates the number of protons, but also the number of neutrons. So mass number equals neutrons plus protons. So the correct answer, so the incorrect one in this case, is letter number C. The second one. Okay. Is it going, the slide?
No,
Yeah.
it's not going. Try to control my screen again. Yes, now it's working.
Okay. Perfect. Okay. Number 2. So we have to consider this reaction, and we have to basically balance correctly this reaction. So usually when you are asked to balance a reaction, there is a kind of order you have to follow. So usually we start from the metal. So in this case, we have lead and sodium. However, if we check sodium and lead in both the reagents and the products, we can see that they have already balanced. So we're going to go next to the iodine. because we see that in the products we have 2 atoms of iodine, whereas in the reagents only 1. So we're just gonna put a 2 instead of B. Now we're gonna go back to the sodium and lead and see if they are balanced. Again, we see that the sodium is not balanced because there are two actually 2 atoms of sodium in the reagents. So we're gonna put 2 instead of D. And then we're gonna check the other one. So we're gonna check the nitrogen, the oxygen, and again, the lead. And we see that they are balanced. Therefore, the correct answer in this case is letter B. So usually when you have to balance reactions, it's just a matter of math. So you have to calculate the difference between the atoms in the reagents and in the products. Number 3 is asking to consider these 5 elements with the following atomic numbers and see which of these has the most exothermic electronic affinity. So we have to proceed step by step. First thing, we have to, of course, know the periodic table. And so according to this atomic number, we can find and we can identify these elements. So we're gonna have to write the periodic table, and we're gonna understand that the first element is arsenic, so with the atomic number 33. The second one is chloride. The third one is calcium. The fourth is beryllium. The fifth is fluorine. And the other one is fluorine, sorry. Now we have to consider these 5 elements and see which of these has the highest electronic affinity. What do we remember from the electronic affinity? So how does the electronic affinity change within the periodic table? We know that the electronic affinity increases from the left to the right, so it increases along the period, whereas it decreases along the group, so from the bottom to the top. So we're going to have to find between these elements the one that is located on the right part of the periodic table, in the uppermost part. The only one between these elements is actually the 5th one, so the fluorine. Therefore, the correct answer here is E. Moving on, we have a stoichiometry exercise, and keep in mind that the stoichiometry is a really important topic in the test, so you have to be really good at resolving these kind of exercises. So number 4 is asking to calculate basically the number of atoms in 0.2 moles of molecular chlorine. So in this case, we're going to have to use the Avogadro's number. The Avogadro's number is really important, so you have to learn it. And it equals 6.22 times 10 to the 23rd. And we usually know that in 1 mole of substance, there are 0.22 times 20 to the 23rd molecules, atoms, whatever. In this case, however, we do not have 0.2 moles of substance, so of chlorine, but we have 0.2. So we're going to first need to calculate the number of molecules in 0.2 moles. So we're going to have to multiply 0.2 times the Avogadro's number, and we're going to find 1.2 times 10 to the 23rd molecules. However, in this case, we do not only have 1 atom of chlorine, but we have molecular chlorine. So we have 2 atoms of chlorine. Therefore, we're going to have to multiply 1.2 times 10 to the 23rd by 2. And we're going to find that we have, in this case, 2.4 times 10 to the 23rd atoms of chlorine. So the correct answer is A. So I have a question in here about the third one. Can you please read it, Chiara, because I cannot see the chat. Okay. I'm just gonna go on and
No, I'm here. I'm sorry, but I couldn't unmute myself. I don't know why. So there is Sophia that says about question number 3, I think referring to the different atoms, if it was
Yes.
necessary to identify them.
Yes, because in this case you have to identify the position of these elements within the periodic table. Because only by doing that you can actually understand which one of these elements has the highest electronic affinity. So yes, so yeah.
And there is also another question about molecular chlorine by Chloe Gina. I hope the name is correct. Is a molecular chlorine already Cl2?
Yes, it's Cl2. So there are two atoms of chlorine. And this is why you have to multiply the final result times two.
Okay, yes, we can move on.
Okay, good. So number 5 is asking us which of these molecules has trigonal pyramidal structure. So in order to solve this exercise, we have to know the features of the trigonal pyramidal structure, because usually these kind of molecules have two specific features. The first one is that the central atom has a lone pair of electrons, so it has two spare electrons. The other characteristic is that it is usually bound to 3 atoms. Therefore, in order to understand which kind of these molecules has this trigonal pyramidal structure, we have to first draw them. So, okay, these are the drawings. So the first one is the bromide trifluoride, and as you can see, it is linked to 3 atoms of fluoride. However, the central atom, so the boron, does not have a lone pair. So in this case, it is going to be a trigonal planar structure. The methane, so the second one that you can see here, it is not linked to 3 atoms, but to 4 atoms, and it does not have a lone pair, so it is not going to be the case, our case, and it has actually a tetrahedral structure. The last two are the ammonium and the phosphorus trichloride. As you can see, they actually are linked, the central atoms, so the nitrogen and the phosphorus, to 3 atoms. So in the first case, the 3 atoms of hydrogen, in the second case, 3 atoms of chloride, and they do have a lone pair. Therefore, the correct answer is going to be D.
Okay, so we have another question about this, which is there a difference between trigonal pyramidal and trigonal bipyramidal?
Um, Pyramidal. Yes, it should be in the atoms of in the atoms that the central atom, the central element is linking. I think it's linked the central atom to 6 atoms, but I'm not sure now, so I'm gonna check and I'm gonna answer you later, just not to make mistakes. But yes, there is a difference. The number 6 is a reaction, an oxidation reaction, and we are already given the reaction that is already balanced, and we, in this case, have to find the element that gets oxidized. So this is the reaction. So first thing, we have to identify the oxidation number. As soon as we have identified the oxidation number, we need to find the one that gets oxidized. What does oxidation mean? Oxidation means basically when an element increases its oxidation number from the reagents to the products, because it basically loses the electron, so it loses the negatively charged, the negative charge, and it acquires a positive charge. In this case, if we compare every element in the reagents with the same elements in the products, we see that the only one that actually gets oxidized is the iron, because the oxidation number is increasing, so from +2, so +2, to +3, so +3. So the only correct answer in this case is letter A. Okay.
Okay, yes, sorry. Go ahead.
Okay, sorry.
Oh, wait, there's another question.
Yeah.
How do we know which oxidation number should I choose for S in order to solve the complete equation?
Okay, so let me go back. Um, okay, I don't need that. So, okay, this is kind of tricky. because the S or the sulfur can have two numbers, so +4 and +6. In that case, you really need to focus on the molecules that you have, and you always have to remember that the total charge, if the molecule is neutral, needs to equal 0. So you try to give to sulfur, in this case, the number that gets you 0 at the end. So it really depends on the type of molecule. There's no rule. You have to make some calculations, trials, and see what works.
Okay, yes, we can move on.
Good. So the seventh one was kind of tricky. And it is asking, given these two isotopes of bromine, whose masses are 78.92 and 80.92, what is the relative abundance of these two isotopes? Okay, so we have to proceed step by step. So I'm just gonna... Okay, good. In this case, so we're gonna have to start from this formula that you see here in orange. And this formula basically is used to find the average mass of a general atom, a general element. In this case is bromine. And this formula equals the mass of one isotope times the relative abundance plus the mass times the relative abundance divided by 100. Okay. In this case, we only have three data here. We have the average mass of bromide, which is given here in the exercise, which is 79.904, and we have the two masses of the isotopes. However, we do not have the relative abundances, so we do not have the percentages, and this is why we're going to call them with X and Y. Later on, we're going to have to plot our three known parameters in this equation here, and we're going to obtain this one. So 79.904 equals 78.92, blah, 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 blah. And this is our equations. However, it is really to work with both X and Y. So we're going to have to find a way in order to work with only one of them. How can we do that? We basically know that bromine has only two isotopes in this case, so X and Y. If it only has two isotopes, the summation of these two isotopes is gonna must equal 100. So X plus Y equals 100. Therefore, X is gonna equal 100 minus Y, or in either case, Y is gonna equal 100 minus X. It's really, it doesn't matter which one of the two we're going to use, either X or Y. In this case, we're going to use X, but you could have also used Y. Then, this is really important, this equation. So X equals 100 minus 10 minus Y, because we're going to plot this into the other equation here. Why do we need to do that? Because if we plot this in here, we're going to only have one unknown parameter, so the Y. So we're going to solve this equation here with respect to Y. And so we're going to find that the percentage, so the relative abundance of Y, equals 49.2. Now that we know that the total amount of bromine is 100, we're basically going to subtract 49.2 from the 100, and we're going to find that the relative abundance of X is going to be 50.8%. So the correct answer in this case is A. Sorry, forward. I know this is really tricky exercise, but once you understand the rationale behind it and the logic, it's kind of easy. So the calculations are not too tricky. So the eighth is pretty straightforward and is asking which of these elements is not a nonmetal. So if it's not a nonmetal, it could be either a metal, so for example, an alkali metal, or a semi-metal. In this case, we have sulfur, chlorine, phosphorus, nitrogen, and silicon. The only one that is naturally a non-metal in this case is silicon because it is a semi-metal. So the correct answer is E. I hope everything is clear so far. Okay,
Yeah,
so
I
we're
think everything I think they're asking a lot of questions, so I think that they have it's pretty easy, they're pretty responsive.
okay, good. So moving on to the ninth. The question is asking which of these following statements about phosphorus trichloride is correct. So this is the molecule that we've seen in the previous exercise, so you guys should know this one. So phosphorus trichloride, as we said before, has a trigonal pyramidal structure. That means basically that the central atom, so the phosphorus in this case, has a lone pair and it is linked to 3 atoms. Why? Because phosphorus belongs to the fifth group, right? So it basically can form five bonds. In this case, if it is already linked to 3 atoms of chloride, it means that 2 of these electrons are free, are not paired, and they're going to represent the lone pair. So in this case, the correct answer is C. So the slide basically summarizes what we've already said so far. Okay, so now we are halfway through this marathon. And this, the 10th is asking, given this endergonic reaction, which of these statements is correct? So we have to keep in mind that an endergonic reaction is a reaction, a not spontaneous reaction, where the delta G, so the Gibbs number, is positive. So it's bigger than 0. So the first statement is saying that an endergonic reaction is always exothermic. This is not actually really correct. Why? Because an endergonic reaction can be either exothermic, meaning that it loses, it frees heat, but it can also be endothermic, so meaning that the heat is not freed, but it's built up, so it's present in the reagents, basically. So it can be either of them. And this is why the first statement is incorrect and the fourth one is correct. The second one is saying that the pressure always changes the equilibrium. This is not true, because according to the equilibrium laws, pressure can only affect those reactions whose reagents are in the gaseous states. So we are not sure. We cannot be so sure that the pressure is gonna change the equilibrium. We have to see the states of the reagents. Number 3, on the other hand, is correct because velocity is directly proportional to temperature. So whenever we increase temperature, we're gonna increase the velocity, and therefore we're gonna increase the kinetic energy also. So the molecules and the atoms, the particles, are basically gonna move faster. Therefore, the correct answer is D. Number 11 is again
Okay.
balancing.
They're telling us that statement 2 is marked as correct.
I think it's,
And the
wait,
correct option on the platform is 2, 3, and 4.
yeah, there must be an error because no, it's not true. Yeah, there must be a mistake in the simulator.
Yeah, thank you so much for
Yeah, thank
telling
you.
us. Yeah. We'll try
Correct it.
to yes.
Um, okay, so number 11. So we are already given the reaction, so we only have to balance it. As I said before, there is a kind of pattern that you have to follow. So you usually start from the metals. In this case, we have calcium and potassium. So we see that in the product we have 3 atoms of calcium, whereas in the reagent only 1. So we're going to substitute A with 3. And the potassium also is not balanced because we have 3 in the reagents, 2 in the product. So we're going to basically exchange this number. So we're going to put a 2 in the reagents next to the potassium and 3 in the product. So metals are balanced. Now we have to check the non-metals. In this case, we have sulfur and phosphorus. And lastly, we look at hydrogen and oxygen. In this case, we see that the non-metal, so sulfur and phosphorus are already balanced. And also the oxygen, because we have 12 atoms in the reagent and 12 in the product. Therefore, the correct answer is B. Moving on to the 12th, so another stoichiometry exercise, we are asked how many grams of CO2 are obtained by burning 29 grams of butane. So first thing that you need to do when you are in front of a combustion exercise, a combustion reaction, is to write the reaction, right? So you have to write basically the reagent and the product. So what are the reagent? The reagent are butane with molecular oxygen, giving off molecule of water and CO2, so carbon dioxide. Later, you have, of course, to balance the reactions, balance the reaction, because we're gonna need the stoichiometric coefficients. So in this case, first thing that we need to do is to find the moles. So whenever you guys feel stuck in a stoichiometry exercise, if you do not know what to do, calculate the moles, because moles are, in the 99% of cases, what is gonna save you. So we're gonna calculate the moles of our known element, of our known molecules, which is butane, because we know that butane has 4 atoms of carbon and 10 of hydrogen. So we're gonna use the moles formula. So we're gonna have to divide the mass of butane by the molar mass. So the grams of butane by the molar mass. And we find that we have 0.5 moles of butane. Then we're going to have to set up a proportion between what? Between the moles and the stoichiometric coefficient of butane and the moles, which are unknown, the moles and the stoichiometric coefficient of carbon dioxide. So what we need to find are the moles of carbon dioxide, since we know the stoichiometric coefficient, which is 8. We're going to find that the moles of the CO2, so carbon dioxide, are 2. And later we're going to have to find the grams, the total grams of carbon dioxide by doing what? By inverting the moles formula. So since we can calculate by the molecular formula of CO2 the molar mass, we basically multiply the moles, so 2, by the molar mass, which is 44. And we're going to find 88, which is the amount, the grams of CO2. So the correct answer here is B. I hope everything is clear so far. I know that stoichiometry is kind of a pain in the neck, but it's kind of similar exercises. So every time you find a stoichiometry exercise, there is a kind of scheme, a kind of pattern that you have to follow each time. Okay, so number 13 is about organic chemistry and is asking which type of isomers are 3-methyl-heptane and octane. So in this case, first thing that you need to do is to draw the molecules, because by looking at the molecules, you can kind of see if they are isomers and which kind of isomers they are. So, okay, this is the 3-methyl-heptane. This is on the right, the octane. What you can see in here is that actually these two molecules have the same molecular formula, meaning that they have the same number of both carbon and hydrogen. What really changes and differs between these two is the arrangement of these molecules. So how these atoms are linked between each other. And this is why this is going to be a chain isomer. Because chain isomers are isomers that have the same molecular formula, but differ in the arrangement of the atoms within the molecule itself. Therefore, the correct answer is E. So what I would do first in this kind of exercises is, again, to draw the molecules, because by looking at them, it's easier to understand which type of isomers they are. Number 14 is asking us to find the correct reaction type. This is kind of straightforward. And in this case, a double exchange, again, is a type of reaction where there is an exchange between the pieces of the molecules in the reagent. In this case, the correct answer is B. It is a double exchange. And if we look at the other options, for example, letter A, this is not actually a simple exchange, but it is a double exchange. Letter C is not a decomposition, but it is a synthesis because it leads to the formation of ammonium, so not its breakdown. Letter D is partially correct because we have the formation of a salt, so sodium chloride, but we are missing one part of this reaction because usually when we have the formation of a salt, we also have the formation of water. So in this case, water is missing. And letter E is incorrect because it is not a double exchange, but a simple exchange. Okay, so correct answer B. Number 15. Considering the following reaction, how can the balance be shifted toward the product? So we're going to have to use Le Chatelier principle in this case. So let's look at the options. So increasing HI, so increasing hydrogen iodide. So in this case, what is going to happen if we increase hydrogen iodide? We're going to shift the balance, the equilibrium, not toward the product, but towards the reagents, because if we add product, we're gonna have also to add the reagents. So it's gonna be shifted on the other way. Okay, lowering the temperature. So in this case, we do not know because we do not know if this reaction is an endothermic reaction or a exothermic reaction. So it might lower the temperature. So lowering the temperature might shift the equilibrium towards the product, but we are not sure. So we're missing data. Increasing the pressure and lowering the pressure. So in this case, pressure does not affect our reaction, and this is because pressure can only affect those reactions where the reagent and the products are in a gaseous state, which is the case in our reaction. However, in order to change the equilibrium, the summation of the stoichiometric coefficients in the reagents must be different from the ones in the product. In this case, they are equal. So we have 2 stoichiometric coefficients in the reagents and 2 in the product. So in this case, pressure is not going to affect our reaction. So the correct answer in this case is E, letter E.
Okay, so we have a question about this one, Maddie.
Yes.
There's Nicola, I'm not sure. I hope I pronounced the name right. That says synthesis reactions are usually exothermic, so this one is therefore lowering the temperature, should shift the equilibrium to the right. So it asks, like, isn't this wrong? Because synthesis reactions are exothermic. So is this one therefore lowering the temperature, should shift the equilibrium to the right?
Synthesis reaction, I mean, you cannot be sure that they are always exothermic. You would have to look at the enthalpy. So I wouldn't say it's correct.
Okay, thank you. I think we can move on.
Yes. So number 16, again, is a pretty straightforward about organic chemistry. And which of these following statements is true? In this case, the correct one is D. This is because hydrocarbons are organic molecules that can be either aliphatic, so linear structure, or cyclic, like benzene. They have high boiling temperature, but they are not so high if compared to other organic molecules. And they are composed of mainly 2 elements, which are carbon and hydrogen, as the hydrogen-carbon name states. Therefore, correct answer is gonna be D. 17 is about bonds, and it's asking which of these compounds contains an ionic bond. Ionic bond is a bond usually between the two elements that have really different electronegativities values, because the delta E, so the difference in electronegativity, equals, it's larger usually than 1.7 or 1.9. And it is usually a bond that we can find between, for example, alkali metals and non-metals or halogens. In this case, the correct answer is C, because we can find the ionic bond in NaCl, so sodium chloride, sodium sulfate, calcium difluoride, sorry, and potassium bromide. So only 4 molecules. So correct answer, C. 18 is again about a dynamic equilibrium, so a reaction. So we are giving a reaction, a synthesis reaction, and we are asked which of these action will decrease the yield of C, so would decrease the product. So if we want to decrease the product, we have to have some sort of events that trigger the movement, the shifting of the equilibrium towards the reagent. So if we want to decrease C, decrease the products, we have to move the equilibrium towards the reagent, so to the left. So if we look at these 4 actions, these 4 events, we see that an increase in A, so an increase in product, would actually shift the equilibrium towards the product, so toward the right. So this is incorrect. An increase in C, so an increase in the reagent, would shift the equilibrium towards the reagents, so toward the left. So this is correct. Number 3, decreased temperature. So in this case, we know that the enthalpy is positive, so it's plus 300. This is telling us that this reaction is actually endothermic because this value is positive. So when enthalpy is positive, the reaction is endothermic. When it's negative, is exothermic. If the reaction is endothermic, it means that the heat is contained between the reagents, so towards the left of the reaction. So if we decrease the temperature, the reaction is going to be shifted towards the left, so towards the reagent. So it is going to decrease the product. Lastly, we have the 4th statement, which is remove B. If you remove B, again, the reaction is going to be shifted towards the right. Towards the left. So the correct answer in this case, okay, it's not working.
Yes,
Okay.
yes, it's working. Wait, go
Yeah.
back. We
Oh,
have 2 questions. One
yeah.
is about the exercise before, so about 17, which is, does ionic bond involve only molecules with 2 elements?
No, actually, no. This is a kind of a misconception. Now you can also find ionic bond in, for example, salts in this case.
And another one, which I think the answer to it is yes, but I mean, I want you to tell me. It's, should we study for electrochemistry?
Electrochemistry? Like,
Yes.
what do you mean by electrochemistry? Like,
Wait, let's hear if Berfin answers.
yeah, just give me some examples so I can understand.
Still no answer, so I think yeah, no answer. So I think we can, if
Okay.
later, if we can move on to number 19, if later you wanna,
Yeah.
get into it deeper, we can talk about it later.
Yes. So the last 2. So 19 is asking how many charged particles are present within this chloride atom. So this was a kind of a tricky question, but it's really fast and easy actually to solve because the correct answer is E. Why? Because it's asking how many charged particles. What do we know about charged particles? We know that we only have two types of charged particles within an atom, which are electrons and protons. Electrons with a negative charge, protons with a positive charge, whereas the neutrons are neutrons particles. So we cannot actually calculate how many charged particles, how many neutrons are present, because neutrons are not charged particles. So the correct answer is E.
Okay, so Berfin hasn't replied, but some other people have. So I think they mean like cells and electroplating, or voltaic cells, electrolysis of molten salts, and aqueous solutions. So I think those are indeed part of the syllabus. Maybe not voltaic cells, but the rest is. Please
Yes,
correct me if I'm wrong,
absolutely.
Maddie.
Yes.
Yeah. So if they are part of the syllabus, yes, you do have to study them. But please like confirm.
Yeah, I confirm. Yeah, that's kind of an important part. The electrolytes, all the parts related to aqueous solutions. Yeah, so I would try to study that part. I know it's really complicated, but there are many exercises about that. So yes. Okay, so the last one, the 20th, is asking how many fluorine atoms are contained in 0.01 moles of calcium fluoride, difluoride. So this is really similar to the first exercise that we dived into. So basically, again, we need to use the Avogadro's number. So if we know that in 1 mole of substance, we have 0.022 times 10 to the 23rd particles, we need to understand how many particles are present in 0.01. So in order to find out this, we have to multiply the Avogadro's number times 0.01. And we're gonna find that in our calcium difluoride, we have 6.022 times 10 to the 21 particles. The exercise, though, is not over yet because it's asking how many fluorine atoms. And we know that in this molecule, we have 2 atoms or fluorine, as you can see from the molecular formula. Therefore, you're going to have to multiply this value, so 0.22 times 10 to the 21 times 2. So the final result is going to be 1.2 times 10 to the 2 atoms. Oop, I went forward. Sorry, Chiara.
No, it's okay. It's okay. Don't worry. So
So
let's
we're
back, please.
over. I
Okay.
hope
So
that...
there is a question before we move on.
Okay.
For question 19, isn't neutron just mass minus protons? So this one. Wait, let me go back.
Can you please repeat the question because I didn't get it?
Yes, it asks if for the number 19, this one, isn't it just to calculate neutrons, mass minus protons?
Yes.
And
Yep.
we have we have another question, which is, are acid-base reactions important for the IMAT? Yes.
Yes, you guys, it's really important, and it's also going to be important when you will enter med school, when you will study physiology. So I would try to, yes. I'm sorry, I know it's really bad, it's tricky, it's difficult, it's hard, but once you get it, it's not that bad, I think.
Yeah, you're never gonna get rid of acid base
Yes.
in
No.
medicine. So my suggestion is try to learn them as early as possible, and like do a lot of exercises for them, right?
Yes, because for example, I'm preparing my physiology exam now because I'm gonna take it like in 2 weeks, and there's like a part about acid balance, especially in the renal physiology. So yes, the sooner you do it, the better it'll be. Trust me.
Yeah. So we're basically done, but not quite yet. Again, we hope you really have enjoyed our event, but please remember to fill out this evaluation questionnaire. It really takes just a little, but it's very important for us. So please do that. It only takes 2 minutes, and you just need to scan this QR code. So please. And remember to follow us on social medias. We are both on TikTok or on Instagram with the same name, which is IMAT.medschool, and here on our YouTube, which is IMAT Medschool IT, where this live will be uploaded. So you're going to be able to find this and all of our previous lives in which we talk about many different things. We also have one last live in which we corrected a whole simulation altogether. So if you enjoyed this event but want to, figure out a bit more, you can go and check that out. And we have another question. Are there going to be more of these events for biology and mathematics, or have they already taken place already? Well, we're going to have one last event of IMAT correction test. So once IMAT 2024 comes out. But if you liked these events, please tell us, please give us some feedback, and we will make sure to reorganize them in the future. Absolutely. If you enjoyed this event, they will for sure take place. This, like, you drive us. So based on how much you like them, we are gonna try to reorganize more of them. But yes, if you're interested and wanna, look at another one, we have had an IMAT orientation day in which we had a half simulation. So we had more exercises like this and a correction, just like the one Maddie did. And again, we had another event with a full IMAT simulation. So you can go check them out. They're back on our profile on YouTube. So you can check those out, please do. And to thank you for coming, we would like to give you a discount code with 15% off of all of our preparation courses, which is valid until the 6th of September. And it's this one that you see right here below, MS_event_3008. So if you're interested and would like to, see me and Maddie more and, join our practice and revision events, you can do that. And you can have also 15% off. So I think it's a, win-win. And since I see no more questions, we really thank you for coming. And this is officially the end. So thank you so much. Please do give us feedback because I seem to think you really enjoyed this event. So we would like to organize some more. And yes, thank you very much. And if you have any other questions, please write them in the comments below. We will see you very soon. Bye, guys.
Bye, good luck.
Bye.